Hello everyone, welcome back to LeetCoding. Today we are solving a very interesting problem from LeetCode Weekly Contest. The name of the problem is Avoid Flood in the City. In this problem we are given an array range, and this array will contain the lake number on which it is going to rain on a particular day I. Let us say the given array is 1, 2, 3, 4. That means that on the first day it is going to rain on the lake number 1, and on the second day it is going to rain on lake number 2, similarly for the third and the fourth day. So what should we return as our answer? Our goal is to avoid flood in any lake. So that means the same lake is going to be filled twice. Now this will cause flood in that particular lake, and we have to avoid this flooding. In case we are not able to avoid this flooding, then we have to return an empty array. That means that we are not able to generate our answer. So we have to return our answer where answer.length is equals to range.length. That means same as the size of the range array. Answer of I is equals to -1 if rain of I is greater than 0. Answer of I is the lake you choose to dry on the ith day if the rain I is equals to 0. So as I told you that the range array will contain those values on which it is going to rain on a particular day I. In case that value is equals to 0, that means that is a dry day. Now on this dry day we can dry a particular lake which is already filled. Let's say the lake number 1 is filled initially, and again it is going to rain on lake number 1, which is going to cause flooding on this particular lake. In case there is any 0 between this, that means in case there's any dry day between these two intervals, then we can dry the lake number 1 and we can again fill it. So that's what we are supposed to do. We have to return our answer in such a way. Now let me explain you how to approach this problem. In the very first example, it's obvious. When it is given that it is going to rain on the lake number 1, only lake number 1 is filled. Similarly, in this, when it is going to rain in the lake number 2, the lake number 2 is going to fill as well, but there's no repetition. Now let us look for another example. Here the lake number 1 is getting filled, then the lake number 2 is getting filled, then we have 2 dry days over here. Then again the lake number 2 is getting filled. Now we see that the lake number 2 is already filled and it is again going to get filled, but there are 2 dry days, so we can use either of these 2 dry days to dry the lake number 2 and then again refill it when it's going to rain again. Similarly, the lake number 1, it was initially filled, but there are again 2 dry days and we can choose either of these. That would obviously depend on the dry day that we have already chosen for the lake number 2. Now let us try to approach this over here. Now let us say that we are on a particular day I. So this is the range array which is given to us, and we are here, and on this particular day it is showing that a certain lake X has to be filled. It is going to rain on that particular lake. Now if this lake is already filled, so it could be filled already, or it could be empty. In case it is already filled, what we have to do? In case it is already filled, we have certain options to do. In case it is empty, we are simply going to make our answer for that particular day I is equals to -1 and move forward. That is obvious. Now if it is filled, we will try to search the last time that this lake was filled. It might be on some other day. Let's say this day was J and this day is I. Now in between this I and J, there should be some dry day, that is the value containing 0. If it is present, then we can use that day to dry this particular lake and then again refill it on the jth day. So this is what we have to do inside this. If we are unable to find such a dry day between this given interval, then we will simply return an empty array. Alright, that means there's no possibility. So this part is done. Now there's another possibility that this value is 0. Now when this value is 0, we can do a certain thing there, but before that we have to see that how we are going to find whether there is a value containing 0 between this given interval. Now for that we can either do a linear search, that is a very obvious thing. A linear search would work between this interval, but then we don't have enough time for that, so we are going to optimize it. We will be doing this with the help of binary search. So for that to happen, here we are storing each dry day in a set. There will be a set. A set in C++ is already sorted, so it is a good structure to implement a binary search on it. So we are going to store the days, the dry days, in this set. So let's say in between this there is the day K, which is a dry day. We are going to store this in the set. Next thing what we have to do is, when we come to such a case which is already filled, we can apply a binary search between these intervals. So we will simply apply a binary search on this given set S. We will find the upper bound. Upper bound will give us the value which is just greater than a given value. So that given value will be the ith value. That the ith day, we have to find the day which is greater than I, and that is present inside our set. That will give us a day, a dry day, which will be just greater than I. Now there could be many dry days like K, L, M, N, but we have to find the first one in these whole list of dry days. Now there's a reason for that as well. Let us take one example: 1, 0, 3, 0, 1 and 3. Let's say we are at 1. Alright, let me traverse from the very start so that we can see actually how our solution is going to work. If we are at 1, then we will simply see that it is empty because 1 is not already filled. So we will store map of 1 as 0. The reason is we have to maintain the day on which it is getting filled also. That is why we are using a map here. Instead of map, we could have used set if we were not concerned with the day on which it is getting filled. So only if you were concerned with whether it is filled or not, we could have used set, but we are also bothered about the day on which it is getting filled. Now let us move forward. Now we see a dry day. As soon as we see a dry day, we will be storing a set as well. That set will be S, and we are going to store the index, that is 1. The day number 3 comes, and again it will fall in this case. It is empty, so we will simply store this again, and corresponding to 3, the day will be 2. Also we will be updating the answer. So answer for 0 is, let us assume that we are going to fill that. So answer for these days will be -1. For this 0 it won't be -1. We are going to override that. We can initially make it -1, and we will somehow do changes in this in future. We will come to that. Next is again a 0, so it is day number 3. So 3 will come in the set. Then again 1 comes, and we find that it is already filled because map of 1 contains something. Now we will see that we will now focus on the interval. The interval will be from the day number 0 to day number 4. Now between these intervals, not including them but between them, if there is any possibility of having a dry day, we do a binary search on this set. Now we find that there are 2 such possibilities, and we have to choose either one of them. So what I was saying, that we will be going with the smaller possibility, and that is the greedy choice. Instead of 1, we could have chosen 3 here, but that would lead to problems. Let us say that we choose 3 here, and now we will move forward. So 3 will be removed from the set. Answer of 3 will become, we have to dry the lake, so it will become 1 because we are drying the lake number 1 here. Next is 3. Now as soon as 3 comes, it is again going to fall on the filled case, and we are again going to do a binary search on S, and we will find that the last time when 3 got filled, it was 2. So the interval is from 2 to 5, not including them but between them. So the possibilities, so when we do a binary search in this range on this set S, we will not find any particular day which will be a dry day, so there's no answer for this case, which is obviously wrong. So instead of 3, we could have chosen 1 for the day number 1. So 3 will be left in the set, and when we do a binary search to find a dry day for 3, we will be able to do that. So in that case, the answer was possible, and this is how we are supposed to approach this. That is why it is a combination of greedy as well as divide and conquer. Divide and conquer is for the binary search that we are using, and greedy is for the choice that we are making here. Now once the agenda is clear, we can move on to the coding part. If you want to try it yourself, you can go ahead. If you want to follow up, let us now go and code this. Let us take a map of type int comma int. This will be for storing the days, and a vector of int answer initially we'll put something here, and is equals to range.size. We also need a set. Now we are ready to visit the range array. If range of I is equals to 0, when it is 0, our task is to insert this day into the set and nothing else than this. If it is not 0, that means that it is going to rain on a certain lake. So let's say if that lake is already filled, if range of I, if it is already present inside our map, we will try to do something. If it is not present inside our map, then answer of that I will be -1, and now we are going to store this inside our map with the corresponding day on which it is getting filled, so that we can further use it. Now if it is already filled, we will try to see if, let me do a binary search on S. Auto A is equals to S dot upper bound M of range of I. This is giving me the starting day. That is the I that we discussed here in this agenda. It is giving me the starting day. So it is giving me the left boundary, and the left boundary is not included in our solution. So that is why we are doing an upper bound for this. If A is not equals to S dot end, that is, we are able to find a particular day, this upper bound will give me the greedy the greedy day as well. So we are going to select the upper bound, that means the next greater value. So it will give me my greedy choice. It will fulfill my greedy choice. Okay. Next thing is, if we are able to find this day, then for this day I will make my answer is equals to rains of I. We are going to dry out this particular lake on that day. And obviously we have to erase this from our set so that we don't use it the next time. Else we will be returning an empty array. Alright. So then we will return our answer. Let us see that we are handling all the cases or not. If map.find that lake, that it is saying that we are already filled. So this is the case for already filled. If it is already filled, then we will search, we will do a binary search. If this binary search is successful, we are going to erase it from the set and change our answer. Else we are going to return an empty array. Okay, and one more thing, in case we are able to find it. Okay, let me do test for all the cases. It's giving me compilation error in m.find in the line number 17. m.find range of I is not equals to m.end. My answer is 0 for these days and it is supposed to be -1. So let me initialize all of them with -1, let's say. Will it give me a right answer now? Okay. Okay, so instead of, so these are the unused values. So for these unused values, I can do something. I should not store -1 there. I will have to store something else. Yeah, I'll have to store something else. And this is required in every case. Now it is okay. Let me try to submit it now. Oh, got accepted. Now talking about the time complexity. What do you think the time complexity would be? First of all, let us make this map an unordered one because we are not doing any binary search on this. So this can be an unordered map. There is a binary search going on here, which is log n, and this whole thing is n, and this is the length of the array. This is the number of the lakes, which could be up to 10 raised to the power 9. The days could be from 0 to 10 raised to the power 5 as well. So the binary search is actually on the days. So it will be log of this range log of 10 raised to the power 5 when we are going to do this binary search. And same, this is big O of n, which is 10 raised to the power 5. So it is n log n solution in total. In terms of the time complexity, in terms of the space complexity, it is going to be big O of n. So this is it for the solution. If you like the video, please subscribe to the channel. Thank you.